Hello, everybody, and thank you for joining us for another JS Drop from ThisDot. Today, Colin Ihrig is joining us to give an introduction to Deno, a runtime for JavaScript, TypeScript, and WebAssembly. Like and subscribe for more weekly JavaScript content, and let's get started.
Hi, everybody, and thank you for coming to my talk. I'm going to be talking about Deno, which is a JavaScript runtime similar to Node.js. So I wanted to start off and talk a little bit about the timeline that Deno has existed in. So all the way back in June of 2018, Deno was introduced at JSConf EU in a somewhat infamous talk by the creator of Node.js, kind of addressing all of the perceived shortcomings of Node and how he had hoped to address them. And at the same time, he introduced the new Deno runtime. Fast forward to August of 2018, and Deno 0.1.0 had been released, which was significant because it was rewritten in Rust. Deno was originally written on the native side in Golang, but Golang and JavaScript both are garbage collected languages. And so it was desirable to only have one garbage collector inside of the process. So it was rewritten into Rust. In May of 2020, Deno 1.0 was released. And then a while later, in March of 2021, a company called the Deno Company was formed around the Deno project. And then fast forward to June of 2021, and Deno Deploy, which is a edge function runtime built on top of Deno, was announced. And in Q1 of 2023, we're hoping to have Deno Deploy reach general availability. So I wanted to talk briefly about growth of the project. So this graph shows GitHub stars over time for Node.js and Deno. The tool that I used to create this graph, for some reason, wouldn't go back to 2009 for Node.js, but the star counts here are accurate. And so there's currently about a 5K difference in GitHub stars between the two projects, even though Node has had a significant head start. And I think one thing to mention really quickly is that GitHub stars are not a real metric for how much a project is used. Anybody can come to a repo, star the project, and actually never look at it again. But we do have some internal metrics that do verify that Deno adoption is increasing. So next, I wanted to talk about kind of the core technologies underneath of Deno. I'll talk about what is inside of Deno, and then just for comparison purposes, what's inside of Node.js if you're more familiar there. So both are JavaScript runtimes that are built on top of the V8 engine, which was a project created by Google, which is what powers the Chrome browser. That's kind of where the similarities stop. So at the native layer, Deno uses Rust, while Node.js is C++. And then V8 itself is a C++ project, so I'll explain in a bit how Deno is able to be written in Rust while still wrapping V8. For asynchronous I/O, Deno uses a Rust project called Tokyo, where Node.js uses a library called libuv. Then for TLS and crypto, Deno uses Rust TLS, while Node.js uses the OpenSSL project. For HTTP, Deno uses hyper and request depending on whether you're on the client or the server. And I have an asterisk here because Deno also has an experimental server called Flash that's kind of under development, which is hopefully and according to benchmarks showing to be the fastest JavaScript server kind of ever developed so far. On the Node side, LLHTTP is used for implementing HTTP. And then finally, for DNS, Deno uses something called Trust DNS, whereas Node uses the C library called C-Aries. So under the hood, Deno is built from open source Rust crates. So we have a crate called Rusty V8, which is a very low overhead wrapper around V8. This is what handles all of the kind of translations between Rust and C++. And conveniently, Rusty V8 also prevents you from, when you install the crate, having to build V8 from source because it's a slow and painful problem. So from here on out, everything above Rusty V8 is pure Rust. There's no C++ code to really worry about. We also have something called Deno Ops, which kind of provides an official API for accessing the native layer from JavaScript or TypeScript. And then all of that is wrapped up into another crate known as Deno Core. So then, taking it up one level of abstraction, you can see I have the same Rusty V8, Deno Core, and Deno Ops here as in the previous slide, but now they're in a bigger crate called the Deno Runtime. The Deno Runtime is where Tokyo is introduced, and then you'll also see these crates that we have for extensions to the core. So like Deno Console is used for implementing the console. Deno Fetch is what implements the Fetch API. Deno Crypto does crypto, etc. And then if we take it up one more level of abstraction, we have the Deno CLI itself. So this is what you would generally download and run. It is distributed as a single executable. The plan is to always have it distributed as a single executable. It makes just kind of deployments and installations and things like that easier for end users. It includes the Deno runtime crate that I talked about on the previous slide, and it also has a really nice integrated tool chain, which I'll talk about later, which does things like linting, formatting, tests, and things like that. And so the idea is that this is everything that you should need to write and to run Deno programs, with the exception of any like third-party JavaScript modules you might install. And so it runs on Linux, Mac OS, and Windows currently, and I have a link here at the bottom of the slide that you can use to download Deno and get started. So as far as dependency management goes, and these are kind of the third-party JavaScript modules I was talking about, it's more similar to a browser than Node.js. So it's ESM only. Out of the box, CommonJS is not enabled unless you're using like the Node compatibility layer, which I'll talk about in a little bit. There's no package.json file. There's no node modules directory with each project. There's a single module installation directory that Deno uses across your entire machine. So, you don't have node modules scattered all over the place. And there's no magical index.js file either. So you have to, specify the name of the file you want along with a file extension. And so whenever you run your application, Deno will actually fetch any dependencies for you, cache them so that you don't have to download them each time, and compile the project. So it's a very nice feel as far as like user experience or developer experience. And then for production apps, because we don't recommend, installing from the internet when you're trying to deploy your production application, we have Deno Vendor, which will kind of pull in all of your dependencies and let you put them in a centralized place, whether it's source control or however you want to handle your dependencies. And then I have a short example here at the bottom that shows how you would download the FS module from Deno's standard library. So we're downloading from HTTPS Denoland std, that stands for Deno standard library. 0.159.0 is the version of the standard library. You could leave that off and you'll get a warning because we do recommend pinning to specific versions. And then /fsmod.ts is the file. We're destructuring out a function called copy, which copies one file from a source to a destination, and then the bottom line is how you would actually use that function to copy a file. Deno does have a standard library, as I mentioned, which is kind of a lot of the core JavaScript functionality. So if you're a Node.js user, think of like the FS module or the HTTP module. So these are guaranteed to be maintained and work with Deno. They're maintained by the core team. Every time there's a new Deno release, the standard library is updated as well. And then you can browse the latest version by just going to deno.land/std. And as I mentioned on the last slide, we do recommend pinning the version anytime you download a dependency. There's no NPM registry, but there is this deno.land/x registry where you can publish your own modules. So this is just an example of what one of those pages would look like. If you've ever browsed, module pages on the NPM registry, it's similar to that, just with a different look and feel. I wanted to talk briefly about the release schedule. So we generally have weekly patch releases with a monthly Semver minor release for adding new features. Releases normally happen on Thursdays. We do occasionally deviate from that, but in general, releases are Thursdays. So far, there's only been one Semver major release, the 1.0 release. So there's not really a set schedule for major releases yet. And there's also not a long-term support schedule yet. So if you're coming from Node land where, that's a thing, it's not there yet. So with all that said, I wanted to show you a quick hello world example. So here I'm importing a function called serve from the HTTP module in Deno's standard library. And then calling serve, I'm passing it an arrow function, which just creates a new response object. If you've used the fetch API, you should be familiar with what the response object is. That just says hello world. And then you can run this with the command deno run -- allow net, which is what will let your application access the network. And I'll talk a little bit about permissions later. And then the name of your file, assuming it's called server.ts here. And all this will do is start a little server. It'll actually print a message. It's part of the serve function, so you don't see it here, but it prints a message saying, what port it's listening on. I believe it's port 8000 by default. And then you can start hitting your HTTP server with some traffic. It's not going to do very much because it's very simple, but just to get started, I think it makes for a good example. So some notable features that I wanted to talk about for Deno: a strong emphasis on web platform compatibility, the integrated toolchain, which I mentioned a little bit at the beginning of this talk, the permission system, and then we actually have a Node.js and NPM compatibility layer, which I'll also talk about. So as far as web platform compatibility goes, Deno prefers to use web platform APIs whenever possible, as opposed to kind of creating bespoke, one-off APIs that are not supported anywhere else. And so I have a list of some of the APIs here. This is a small subset. There's many more than this. But you can use things like cache, structured clone, web crypto, blobs files, WebSockets, etc. And then Deno is actually listed on the browser compatibility tables, which is shown here on the right. So if you look at this screenshot, the two far right-hand columns are for Deno and Node.js, and you'll see that Deno has a nice little check mark. It supported set timeout since the 1.0 release. Node.js has also supported set timeout since 0.10, which would have been many years ago at this point. But you'll see they don't have the green check mark, and that's because Node's implementation is not standards compliant. So it returns a timeout object, which is kind of a custom Node.js thing, instead of a timeout ID, which is what the spec calls for. So just some examples of Deno's kind of dedication to web platform compatibility. Next, I wanted to talk about the integrated toolchain. So Deno has all of these things and more built in, whereas with Node, for the majority of these things, you have to install some third-party dependencies. I've listed some here. There are also other options. So, for example, I don't know. For a bundler, I listed Webpack. Obviously, there's many bundlers besides Webpack. So that was just the first one I listed. But yeah, Deno gives you a linter and a formatter right out of the box, so you don't need to worry about configuring ESLint or Prettier. Version management is a big one. Deno has Deno Upgrade, whereas on the Node side, MVM is probably the most popular option for version management, but I don't think it even supports Windows. So there's different things you might have to mix and match depending on your platform, whereas Deno gives it to you out of the box. Deno also has a documentation generator, a task runner, a built-in bundler. Deno and Node both have built-in test runners. Node just recently got this in Node 18, and actually used the fact that Deno had one as a little bit of motivation. You can actually compile Deno applications into a single binary using Deno compile, whereas on the Node side, if you've used tools like PKG to do similar things. And then as far as TypeScript support goes, it's a first-class citizen in Deno, so you can just call Deno run in the name of your application. And if it's TypeScript, it'll just work, whereas with Node, you'll either need some transpilation or something like TS Node. And then you can see all of the different subcommands, because this is not a comprehensive list, if you just run Deno -- help. Next, I wanted to talk about the permission system. By default, Deno can't really access very much of the outside world. So you have to explicitly give it permissions. And so there's a number of flags that are built in. So for example, accessing the environment variables would require -- allow env. High resolution time, which can open up certain attack vectors, is also not allowed. So allow HR time is a flag for that. If you need to make any network connections, -- allow net is required. For doing foreign function interface work, we have the -- allow FFI. -- allow read and allow write are used for accessing the file system. Allow run is for spawning child processes. And then if you just kind of want to go with the Node.js kind of YOLO approach to permissions, there's the -- allow all or -A. A few things to note. If you're allowing subprocesses or dynamic libraries to be loaded, those are not restricted. So once you do that, you're kind of opting out and letting these things do whatever they want. Some of these flags can actually be configured even further. So for example, say I only wanted to allow my application to talk to specific websites or read specific files. You can actually configure those flags with that specific information. And these permissions do apply to the entire application. So there's no way of saying, I want to load this module and I want to give this module these specific permissions. So next I wanted to talk about Node.js compatibility. So Deno does have a pretty I don't know, feature complete Node.js compatibility layer. So a lot of these Node core modules are also implemented in Deno. For Stream, I have an asterisk here because it actually uses the readable Stream module from NPM. So everything is guaranteed to be kept up to date with the latest and greatest in Node. And so the standard libraries compatibility layer is currently tracking the latest version of Node LTS. So just last month, Node 18 became the active LTS release. So Deno is now tracking that. So you're always, not necessarily the latest and greatest because that would have you on the current release, but the latest and greatest while also stable release, we'll say. And then a big thing that we just announced recently was NPM compatibility. So say I wanted to import an Express server, I can just write npm : express and then optionally given a semver version string on the end. And Deno will pull that package from NPM for you, and then you can use it just as if you were writing Node.js code. And so the reason for implementing this was, if you look at the graph on the right, NPM dwarfs every other package ecosystem in the world by quite a lot. And so, giving Node.js developers a bridge to come over to Deno and continue to use the applications that they were already familiar with seemed like, an obvious win. So it's we've been implementing it. Actually, I have Deno run -- unstable at the bottom here. We no longer need the unstable flag. I should have changed that. But you can run your Node code just like that. And then some other recent things that have landed in Deno. We always keep V8 up to date as much as possible. Node API has been implemented in Deno. Some subcommands, Deno bench for benchmarking, Deno task. Deno.spawn is a new way to spawn child processes in Deno. And just, I'm not going to list everything, but you can easily look at the change logs online. And, if you have Deno installed, just run Deno upgrade and you'll automatically get the latest and greatest. So the next thing I wanted to talk about was Deno Deploy. So Deno Deploy is kind of a software as a service offering of Deno. It's an edge runtime, so it's actually built from all the same crates as the open source runtime, with some tweaks to make it more appropriate for running in the cloud. So not providing certain APIs that don't make sense in the cloud, or providing more restrictive versions of them. And so Deno Deploy is currently running in over 30 regions globally. And we're constantly adding new ones. I have a link to a blog post here that kind of talks about how this is built under the hood in more detail. But currently it's used by Supabase and Netlify. So we do have some serious traffic actually going through the system. I'm going to demo Deno Deploy here in a second. But I just wanted to mention that, it does have a very generous free tier. So yeah, I encourage you to try it out. It's very easy to get started. So I wanted to wrap up the slides here with some links to what I consider to be some important links. So the documentation is at deno.land/manual. The standard library that I talked about earlier is at deno.land/std. The third-party module registry is on deno.land/x. You can actually on GitHub view the source code for the standard library or the CLI itself. We do have a Discord with the link here. The community is pretty active, so if you have questions or just want to get involved, I would recommend joining the Discord channels. And then the link here to Deno Deploy, which I'm going to talk about in a second. And with that, I'm going to switch over to my browser. So I'll stop the presentation, share a different tab. And so now you should be seeing deno.com/deploy. This is kind of the Deno Deploy landing page. We have a couple of example applications here that you can actually go and look at and see how Deno applications are written, if you possibly get some inspiration. So we have a getting started with a blog out of the box, a chat application, a Calendly clone here. And then we have an e-commerce shop where you can actually purchase Deno merch. It's powered by Shopify. It's a real shop. You can actually have these things shipped to your house. And I'm not going to click on it, but we have this Discover Showcases link here, and it'll actually take you to a page that has even more showcase applications that have been kind of built by the ecosystem. And yeah, you can browse those as well. So I'll go ahead and sign in to Deno Deploy. I think I should already be signed in. Yeah, so it'll just redirect me here. So this is what the project dashboard looks like. So I actually host my blog on Deno Deploy as well, but I'll come back to that in 1 second. So I want to go ahead and create a new project. You can set up a project linked to GitHub. I'm not going to do that here. I'll show you when I talk about my blog what that looks like. But we have this playground that you can kind of, as the name kind of implies, just go in and play around with Deploy. So I'm going to create a new playground application. So we wait for this to spin up. And you'll see it actually gives you a little like hello world application similar to what I showed earlier in my slides. So this is your code. You can, any type of JavaScript or TypeScript should work here. You can kind of toggle between the languages that you want to use. And then we have logs that are streamed here. So for example, if I wanted to change this and say console.log, yay, and then do save and deploy, finalizing. And so you'll see here that US East 4 is the region that's geographically closest to me. The application started up in 1.72 milliseconds after it was deployed. Here's my console log statement that I actually wrote. And then my server is now listening on port 80 right here. And then over here, you can see the hello world that it's printing. I could change that and save again. So hello world 2. After a couple of seconds, it should refresh over here automatically. Yep, hello world 2. It gives you a URL on the deno.dev domain that you can, put this into a browser, play around with it, share it, whatever. You can refresh it and things like that. So that is kind of how the playground works. So now I'm going to go back to the projects page. And I'll look at my blog a little bit. So this is much more involved than the playground. So I have a production deployment here. I have the following domains all linked to it. So this blog-cjihrig-com, this is provided for you by Deno. But then I also went ahead and actually set up certificates and DNS and all that, so I can use custom domains here. I'll show you that in 1 second. The last time I updated my blog was 4 months ago. I'm bad at keeping my blog up to date. But then a list of the latest deployments, so you can browse through them and see things in your history. So you could go back to older versions and things like that. You have a quick little summary over here about what traffic has looked like for the past 24 hours. You can adjust that a little bit for different times. We have an analytics tab that's built in, so you can see things like how many requests you're receiving over time, how much data has been transferred in and out. So the green here is data coming in, the blue is data going out. It makes sense that the output is a lot more than the input because it's just a blog. And then how much CPU time we're using per request. So apparently I'm doing a lot of CPU here. And then you can also configure this based on 24 hours, 7 days, or 30 days. There's also streaming logs. So this shows you kind of stuff like what pages people are loading. Anything that generates kind of like a console log or something like that in your application will show up here. So if I were to actually come here and go to my blog, it'll load, and then I should get in a few seconds, something will show up here saying, that a certain page was requested or something like that. We also have crash information. I'm not sure what happened here with the no such process error, but yeah, we have crash information. All of our deployments. So this is the same information that I showed you on the overview tab. So you can go back and look at older versions of your deployment. And then some settings. So this is what it's called. This is what the Deno.dev name is called. You can change this if you want to. Set up environment variables. This is the Git integration here. So I have a repo. My GitHub username is CJ Ihrig. The repository itself is blog.cjihrig.com. Main.ts is how you would start the blog if you were running it as an application. Down here, you can transfer projects or delete them. I'm not going to do that. And then you can set up domains. So I have, cjihrig.com as well as blog.cjihrig.com here. We do have support for wildcard domains, but I had set this up before we did. And then you can add new domains here. So you could say foo.com, save it. And then when you go in to set it up, it gives you some DNS records. I'm not going to actually set up this domain, but you can put these DNS records into your provider's DNS configuration and then validate it. That way it'll show that you own the domain. You can provision TLS certificates. So you can do HTTPS and all of that fun sort of stuff. And that is kind of my whirlwind tour of Deno Deploy. Thanks for coming to my talk. Thanks for listening at home, and have a good day.